Okay, this video is about standard normal distribution. We talked about normal distribution last lesson about this general shape of this bell curve. It's symmetrical. Um, there is a peak in the middle, and as you get further and further away from the peak, the values get smaller and smaller. We also discussed that normal distribution is found in a lot of different naturally occurring measurements, so things like height, weight, length of a snapper, kiwi egg weight, all sorts of things. Anything that's natural variation to it will follow a curve. The only difference between these groups will be a standard deviation and the mean. So the mean is signified with a mu, a Greek letter m, and standard deviation is using a sigma. The mean is the center. Also used X bar in populations, and the standard deviation is the spread. So two groups could have the same mean, but different standard deviations, meaning that the curve would be wider. The other thing that we talked about is that the standard deviation is defined by certain proportions. That one standard deviation between above or below the mean contains 68% of all the values. Two standard deviations above and below, we end up with 95% of all the values, and 99% of all the values are between three standard deviations. We don't normally go past three standard deviations because, as you can see, the proportions are so small that they're insignificant to what we're doing. So each of these standard deviations divide up in different proportions. So one standard deviation below is 34, one standard deviation above is 34 as well. So what does that mean? It means with questions like this, we can use it to try and answer things about the group that we've got. So we've got the weight of avocados is normally distributed with a mean weight of 350 and 350 grams and a standard deviation of 25 grams. So looking at the bell curve, what that means is that we've got a mean of 350 grams and we've got a standard deviation of 25. So it means on this graph, what I can do is I can say this is 350 in the middle, and one standard deviation above is 350 plus 25, 375. Two standard deviations, another 25, so that's 400, and 425 would be three standard deviations above. Now working the other way, I take away a standard deviation, so it's 325. Take away another 25 for two standard deviations below, so that would give us 300, and then 275 would be below. What that gives us the ability to do is I can say, in this group of avocados, we would expect 13% of them to be between 300 and 325 grams. Now, you can obviously talk about if you had a minimum weight that we're not going to sell avocados less than 300 grams, then I know that of all the avocados, I'm going to have the sum of all of that, which is roughly 97.5%. I'm going to have all of that to be able to sell. So that's the type of thing we can do. So the questions we're going to look at is what proportion measure less than 325? What proportion of the avocados measure between 275 and 325? And what proportion of the avocados measure more than 400 grams? Between which values are 68% of the measurements? And what proportion of the avocados weigh less than 387.5 grams? So looking at this first question, we're talking about 325 and what measures less. So that's everything below it this way. So if we shade that in and we have these three proportions that we can add together. So we get our, once you've done the calculation, you can see that there's 15.86% of the avocados weigh less than 325. Okay, the next question is what measure of avocados measure between 275 and 325. So that's obviously two proportions there. Let's get our calculator out again and we can work it out. Okay, and that's once you've added those proportions together, you get 15.73. Moving on to C, what proportion of avocados weigh more than 400? So 400's up here, that's this section and this section. So you got two values there to add together. Again, the calculator. Okay, you can see that we end up with 2.27%. So the big trick is to work out and look at the language when it talks about more or less to work out where you need to do it. Okay, find the values where we have 68%. So we talked about before, we've got 34 and 34. That's between one standard deviation above and one standard deviation below. So X would be equal to 325 and Y would be equal to 375. Okay, and E, the last question, so it's asking us what proportion of avocados weigh less than 387. So if I take a look at my graph, there's a bit of a problem with this one. I'll give you a moment to see if you can work out what it is. Okay, hopefully you've noticed that I've only got values for 375 and 400. And what we're looking for is 387. So this model we've got is only a set model where we know the proportions for one standard deviation and one standard deviation increments. The result we've got here isn't in one standard deviation increments. So we need to, basically we need a new model. We need to work out what standard deviation models we've got. So if we take a look at another bell curve, different from the one before, this one's got the proportions divided by, rather than one standard deviation, so it's divided into halves. Okay, so first thing we need to do is we need to apply the mean is equal to 350 and the standard deviation is equal to 25 grams. Okay, we're going to apply that to the graph, and then hopefully our 387.5 might fit. There we go. So I've added in the numbers. So with the question we are looking for 387.5, and you can see now I have 387.5. So I need all of this area. So luckily it fits in. So 387.5 is 1.5 standard deviations above the mean. And so we've got a choice here. What we could do is I could go through and add up all the little probabilities together, that I've shaded in, or I could realize that these things are not less than 387.5. And what I could do is, so the probability that x is less than 387.5, that is equal to 1 take away the probability that x is greater than 387.5 grams. So for me to do that calculation, what I could do is add up those circled variables, so those circled proportions, and I can get my calculator for that. So because it's a percentage, I can take away 100 from 100, the 4 sections, and that gives me 6.7. So 6.7% is equal to this bit, which is more than our value. So the rest of it should add up to 93.3%. So you can see that's one change from the previous graph that we looked at, that you have to, that because we had a value that didn't fit exactly into a standard deviation, we had to come up with one. But what if it was 388 or something like that, that it's not perfectly a half? We'd have to have another standard deviation as well. So statisticians had this problem that they came up with something called, to solve this problem of having to have different values to be able to answer these questions, is that they came up with the standard normal distribution, where they didn't worry about what the values were, but they talked in terms of standard deviations. Okay, the scale of the standard normal curve is -3 to +3. 0 represents the mean. -3 is 3 units of standard deviation below the mean, and 3 represents 3 units of standard deviation above the mean. Z is the standard normal measurement, and it tells us how many standard deviation x is away from the mean. In other words, if you have Z is equal to 2.141, it means 2.141 standard deviations. So that might be a little bit confusing to start, but hopefully it starts to make sense. So the first thing we need to think about is taking real values and calculating Z values from them. And the reason why we have to do this is because of all these different normally distributed. So all of these values, these avocado carrot lengths, are normally distributed, but we can't have a chart for every single one of them. So we talk about normal distribution, things in the real world being X, and standard normal distribution being Z. Okay, so to convert a standard normal distribution, it's a pretty simple calculation. Is you take Z is equal to whatever the real world value is, X, take away the mean, divided by the standard deviation. So what that calculation does is it works out the difference between your real value and the mean, and then sees how big that is compared to the standard deviation. All right, so okay, so here we've got a problem of trying to find the Z value from a real X value. So we've got X, we've got mean, we've got the standard deviation. So what we can do is replace those values. We replace the mean and the standard deviation, and we end up with this calculation. So 34 take away 26 becomes divided by 5 becomes A over 5, which is 1.6. So this value means that we've got 34 is 1.6 times higher than the mean of 26. This time we've got another example. We've got 4 and 10 and 27. So what we can do is put them into the equation. We end up with -13 over 10, which means -1.3, which means 27 is 1.3 times lower than the times the standard deviation lower